So what is Fourier analysis? Before we can do Fourier analysis, or Fourier analysis, I should say, we start with the Fourier series. So Fourier was a very famous French intellectual. In fact, he was like amazingly famous of his time. And France, has this amazing tradition, very beautiful tradition, that they they allow their greatest intellectuals, they give them a lot of important official positions. And Fourier had one of these positions. So do you know of any other French mathematician who has an important position these days? You guys follow
Cedric
French?
Villani.
Exactly. And what makes Villani unusual as a minister?
I don't know. He wears some 18th century outfit, and he like opposes Emmanuel Macron. Like,
Yeah, although they're friends.
yeah.
So Villani is a recipient of the Fields Medal. I don't know if you've heard of the Fields Medal.
The Nobel Prize for Mathematics.
It is equivalent, if not more prestigious than the Nobel Prize. It's only given once every 4 years to 4 people. And when it's given, the recipient must be below the age of 40. Okay, so, and it's given by the Fields Institute in Canada. And so it's a very, very prestigious, the most prestigious prize given in any intellectual endeavor in the world, in my opinion. So Villani is a recipient of the Fields Medal, and he also happens to be the education minister, of France. I think education or science. I think science minister. Yeah, something like this. So I wish we had that tradition in Bangladesh. Okay. So Fourier was such a very famous intellectual, and he had some sort of public office. And one day a young man, his name was Champollion. He was very young and he was very bright, and he somehow came to visit Fourier. And in Fourier's office, he saw a little replica of a stone tablet. And the stone tablet had on it some scribbles in pictures. And Champollion asked Fourier what it meant. And Fourier answered that this is a copy of what is now known as the Rosetta Stone, which was found in Egypt, and no one knows what it means. It also had some, and Champollion very confidently said to Fourier that when I grow up, I'm going to figure out what it means. And you know what? He did. Champollion is the one who unlocked the hieroglyphics, the Egyptian hieroglyphics. And so, yeah, I think that's a very interesting and inspiring
Did he use
story.
like mathematics to figure out like the occurrences of words and stuff like that?
No, I mean, not mathematics per se, but of course, logic. The thing that he used, of course, because when you decode a language, you have to be a logician, right? Linguistics is his own field of logic, right? I mean, all he knew was that there were these words, so to speak, which had this borders around them, and those words meant Ptolemy, which was the name of the Egyptian king during which time this was actually. So that was a clue that he knew at least what one word corresponded to. It was Ptolemaios or Ptolemy. And then I don't know exactly. So sorry, my partner in crime is here. So the other thing is that you can also look up the story of the decoding of linear B. Okay, linear B was a very famous and ancient, I think, probably Babylonian or some language. It's like one of the last languages which was decoded, and it was decoded by an architect. And that's also a very fascinating story. A British architect.
Was probably from Greek origin.
Possibly, yes, I think so. Yeah. And
there is a TED video on that is very inspiring.
Okay, it's also a bit of a sad story because after the architect decoded linear B, he fell into a deep depression, and then it said that he committed suicide. So anyway, so I want to just before we get into a serious topic, I want to mention the Voynich manuscript. I'm not exactly sure how to spell Voynich. Does anyone know how to spell
Voynich?
Voynich. The Voynich manuscript.
Maybe the architect stumbled upon statistical mechanics in linear B language.
Right. Yeah, like Boltzmann and Ehrenfest. So the Voynich manuscript is a manuscript which has been handed down, and it's named after, like, I think the first guy who one of the shopkeepers or who found it, and it's kept in Yale. And if you go to the Yale website, you can get the a very high resolution facsimile of the manuscript, and it's one of this manuscript which is yet to be decoded. And there are lots of theories, a lot of them conspiracy theories about what it means. Some people think that it's actually a humongous joke, and that's not outside the scope of possibilities, to be honest. So the Voynich manuscript is something that has also not been decoded. And in this vein, I want to at last mention a short story by the famous Argentinian writer Jorge Luis Borges. And Borges wrote a wonderful short story called, I think it was called Tlon Ukbar and Obris Tertius, something like this. And this is a great story, and it's about a group of people discovering an encyclopedia for a different world, for a different reality. And the short story is basically a description of how they find this encyclopedia of this completely different reality, and what are the laws of physics, and what are the laws of that universe. I highly encourage you to read this. It's a very short story. It's like a few pages, but it's quite amazing. Okay, so let's go and do some Fourier analysis, okay? So Fourier analysis deals with, sorry. With representing L2 integrable functions, defined on some interval, but for us it's R3, because we are dealing with three-dimensional space, in terms of plane waves. e to the power I kx etc. Right? So so often for for formulation we will deal with, for simplicity we will deal with just R, but the generalization to R3 should be obvious. Okay. So as I said, we start with the Fourier series. Okay. So what is the Fourier series? So, suppose that we have a function psi of x, defined on an interval x between L by 2 to minus L by 2. Okay. So let's draw a function that. So suppose this is L by 2. This is minus L by 2. And we have some function like this. Okay. And let's call this function psi of x. Now, let us extend this function to the whole of the real line. And by translating it, translating it by, say, m times L, where m is some integer. Okay. So that means that we take this function and we basically say, okay, let me make a copy of this here. And then let me make a copy of this. Oops. So I'm translating it to the whole of the real line. Okay, so you get the idea, right? Now, so we have, as a result, a periodic function. So let's call this periodic function phi of x. So here, in this interval, phi of x coincide with psi of x, but phi of x is a periodic function. So, this way, we get a periodic function phi of x, which coincides with our original function psi of x, when x is between L by 2 to minus L by 2. Okay, any questions so far?
Sir, what's the m here? Like just a multiplier or something?
Yeah, m is an integer.
Oh.
So all I'm saying is that, we are taking our original function and we are, it's only defined between minus L to plus L, right? And what we will do is that we are going to translate it by an integer times L, right? This is L. This,
L/2 minus L/2 ওখানে ফাংশন মানে এটা ডাবল ভ্যালিউড হয়ে গেল না মানে
oh, you mean at this point? At this,
L/2 yes sir এখানে
yeah, yeah. So we can just like, it can be discontinuous there. You're allowed to have a discontinuity. Okay. So
Okay,
you
sir.
can say, okay, is that all right? It's, or what you can say is this. You can say this, and then we don't have a problem, right?
yes sir
Sir,
But
so
yeah.
psi x is the longer extended translated version, and phi x is just the same thing in minus L/2 to L/2.
Yeah, it's the other way around. Psi x is our original function, and phi of x
okay.
is the extended one. Yeah, it's just a notation, you know. Okay. Okay,
Sir.
now, yeah.
তাহলেও তো মানে এটা রিয়েল লাইনে এক্সটেন্ড হলো না মানে আমরা তো ওই যে ওই পয়েন্ট গুলো ডিসকন্টিনিউয়াস থাকতেছে যে মানে আমাদের হোল রিয়েল লাইনে তো হলো না ওই পয়েন্ট গুলো বাদে
Right. Okay, so you're worried about those points.
মাইনাস L/2 আর প্লাস L/2 তে যদি ফাংশনটার মান সেম হয় তাহলে হচ্ছে মানে এটা কোইনসাইড করে ফেলবে তখন হচ্ছে কন্টিনিউয়াস থাকবে
Yeah, it doesn't have to be continuous. That's the point. It doesn't, yeah, you don't need it to be continuous. Okay. Periodic function, for example, functions like this, the sawtooth wave, this is a periodic function, but it's actually not continuous at this point, okay? So yeah, I think we should actually have that. So at this points, they're double valued. They can be double valued. Which is another way of saying that they're not continuous at the point. Well, I think, yeah, there's a mathematical subtlety there that let me think about that and get back to you in the next class. So I think you have a point, Yan, but I'm not exactly sure, if I think, yeah, this is the way to do it, and then to say that, okay, at this point, our function phi of x is a discontinuous function.
Okay, sir.
Okay.